So we're finishing up chapter 12 and we're talking about percent yield and limiting reagents. In any chemical reaction, an insufficient quantity of any of the reactants, which are our starting products, okay, will limit the amount of the final product or final products, okay, that forms. So if you have 5 loaves of bread and 1 piece of cheese, you can still only make 1 grilled cheese sandwich, right? The cheese is the limiting reagent. So in our equation, we have 2 bread plus 1 piece of cheese, or 1 cheese, or just C, makes B2C, right? So even if you have 100 pieces of bread and 1 piece of cheese, you can still only make 1 sandwich, okay? The cheese is the limiting reagent because it's what's limiting. In this example here, it's the one that's limiting how many sandwiches you can make, and the bread is the excess reagent because we have bread in excess, okay? So when we have a limiting reagent, it's what's used up, the reactant that determines the amount of the product that can be formed, and the excess is what we have left over. So often when I am doing reactions with Benny and Rosie and we're using baking soda and vinegar, I'll put a bunch of baking soda in a cup or in like a muffin tin, and they add vinegar to it and it bubbles and foams. And what I'm left over with, or what we see when the bubbling and foaming is done, is there's still white powder at the bottom. So the vinegar is the limiting reagent. It's been all used up, and then we have the baking soda in excess. So you've probably seen something similar to that. We are going to look at questions 12.8 and 12.9 from the book. You can sort of follow along. I'm going to do them on Notability, but you can see what I'm doing, and then we'll do some practice problems after. So I'm going to switch to Notability, and I'm going to start with 12.8. Okay. So we have a reaction of copper and sulfur, and what we get is copper 1 sulfide, okay? So if we react 80 grams of copper and 25 grams of sulfur to make copper 1 sulfide, which one is the limiting reagent, right? Okay, and we know here that we have 2 moles of copper react with 1 mole of sulfur. That's what we're looking at here. We have a 2-to-1 ratio, okay? Now, the first thing that we need to do is use the molar mass of both copper and sulfur to determine how many moles of each we need to use, okay? So our molar mass of copper from the periodic table is 63.5 grams per mole. And our molar mass of sulfur is 32.1 grams per mole, okay? So what I want to do is start with the amounts that were given in our problem and convert to moles. So 80 grams of copper, okay? 1 mole of copper is 63.5 grams. And so what that gives us is 1.26 moles of copper. And we have 25 grams of sulfur. 1 mole of sulfur is 32.1 grams, and that is 0.779 moles of sulfur, okay? So now we need to convert our moles of copper to our moles of sulfur, and you can do this either way. I'm just going to start with copper, and I'm going to say 1.26 moles of copper. And then I'm going to go from one to the other thing. So I know that I have a 2-to-1 ratio, okay? So 2 moles of copper is 1 mole of sulfur. And when I do that, I know that I get, or when I plug and chug, I get 0.630 moles of sulfur. And what that means is that for every 1.26 moles of copper, I need 0.630 moles of sulfur. So looking at my original given amounts, I had 80 grams of copper, which was 1.26, and I had 25 grams of sulfur, which is 0.779, and I only need 0.630. So you can see, hopefully, that sulfur is my excess reagent, okay? Sulfur is my excess reagent, and copper is my limiting reagent, okay? because I only need 0.630 moles of sulfur and I actually have 0.779. So I have more than I need, okay? So copper is my limiting reagent. And does that make sense? It does make sense because the ratio that we're given of moles of copper to moles of sulfur was less than 2.1, 2.2 to 1, sorry, because we have 1.26 is 0.779. Okay, we could do it the other way too, and we could say how much copper we do we need from sulfur. So you could say, if we start with 0.779 moles of sulfur, and we're going from 1 mole of sulfur to 2 moles of copper, then what we need is 0.779 times 2 is 1.558 moles of copper. And we don't have that. We only have 1.26 moles of copper. So again, copper is limiting. Okay. Now let's look at problem 12.9. Okay, so 12.9. And you can follow along with these. They're on page 402 and 403. Okay. So 12.3 says, what's the maximum number of grams of copper 1 sulfide that can be produced when we have 80 grams of copper and 25 grams of sulfur? Okay, so how many grams of copper 2 sulfide? So we know that copper is our limiting reagent, so we're going to use this 80 grams of copper. Okay. I'm just going to go back and do what we did before with converting it like a normal stoichiometry problem. 1 mole of copper. And if I go up to I'm trying to get to copper sulfide. This is my step 2, figuring out, I'm going from copper to copper sulfide. So it's a 2 to 1 ratio, so 2 moles of copper on the bottom because I'm getting rid of that, to 1 mole copper 2 sulfide. Okay, and 1 mole of copper 2 sulfide, and the molar mass of this is 159.1 grams of Cu2S. Okay, so if I plug and chug, I get about 100 grams of copper 2 sulfide. Okay, so this is the amount. And I had to start with copper again and not sulfur, even though I had 25 grams, because this is my excess reagent. I have more left over when I'm done, and this is my limiting. Okay, so we'll do more practice problems with these. The last thing that I wanted to talk about today was percent yield. So we always have whenever we're doing reactions in a lab, we have a theoretical yield. So the maximum amount of product that can be formed from given amounts of reactant, right? So if you have 10 slices of bread and you have 5 pieces of cheese, you theoretically can make 5 grilled cheese sandwiches. But let's say your little brother comes in, and I know this can be reduced, obviously. I'm just saying, let's just, I'm just posing a problem. Let's say your little brother comes in, he's really hungry, and he eats 2 of your pieces of cheese. So now you have 10 pieces of bread, but only 3 pieces of cheese. You cannot make 5 sandwiches anymore, right? You cannot make 5 sandwiches. We can only make 3 sandwiches, right? Because our cheese is our limiting reagent, okay? So the theoretical yield is how much you should be able to produce. My actual yield is how much I actually produce. And in the lab, sometimes we make mistakes and things don't always go to plan. Human error, we might mass things incorrectly or measure things incorrectly volume-wise, or we might spill stuff on the counter, on the lab bench. And so what we actually produce is really important. That's our actual yield. So our actual yield divided by our theoretical yield, what we should produce, times 100 will give us our percent yield. And the percent yield is basically a measure of how well a reaction was carried out in the laboratory. The efficiency, the higher the number, the better, right? Okay. Better yield. We always want 100% yield. It's very often it's rarely achieved. So I'm going to leave you with that, and then